So in this example, we are trying to find closed formulas for sequences by comparing the sequences that were given to some common sequences that we already know the formulas for. So the four that we're kind of trying to compare to are the square numbers, the triangular numbers, the powers of 2, and the Fibonacci numbers. All right, so we'll start down here with A, which is the sequence B sub n with n bigger than or equal to 1. So notice down here that our index starts at 1, and these are the numbers in our sequence, 2, 4, 7, 11, 16, 22, etc., dot, dot, dot. Okay, so we want to compare it to these four sequences that are given to us, the ones that have kind of known formulas. And when we're doing that, the one that kind of sticks out to me as being most similar is the triangular numbers up here. So the numbers in our sequence B sub n are all one more than the triangular numbers that are given in that sequence. Okay, so we're just kind of comparing it to the ones that we know to see what we notice, and we can say that these are all one more than the triangular numbers. Okay, so what does that tell us? That tells us that our guess would be that B sub n is going to be equal to, I'm just going to write this in words first, triangular numbers plus 1, right, since 1 plus 1 gives us 2, 3 plus 1 gives us 4, 6 plus 1 gives us 7, etc. All right. So what is the formula for the triangular numbers? That's our right here, the T sub n, which is n times n plus 1 over 2. And then since the numbers in our sequence are one more than that, we're going to stick a plus 1 there at the end. All right. So we could simplify that into one fraction. I'm not going to bother doing that right now since we're just kind of looking for the formula, but it might be a good idea to check to see if this formula actually matches up with the numbers that were given to us in the sequence. So again, I'm going to point out that the sequence starts with the index of n being bigger than or equal to 1. So we start with n equals 1. And what I want to do there is just plug in 1 for n into this formula here to see if it actually gives us the first value in our sequence. And we'll do this a couple times just to kind of check to see that we have the right pattern going on. All right, so when we do this, we get 1 times 2 over 2 plus 1 should be equal to 2, right, because these ones cancel out, and then we have 1 plus 1 is 2. All right, the next one, B sub 2, would be 2 times 2 plus 1 over 2, which would be 3 plus 1 is 4, and this 4 matches up with the second number in our sequence, so that's a good thing. We'll just check maybe, 2 more just to kind of verify that we're on the right track. So 3 times 4 is 12 over 2 is 6, plus 1 is 7, and again, that's good. We'll check n equals 4 just as one more. So what is that? 4 times 5 is 20 over 2 is 10, plus 1 is 11. Okay, so what we're doing, again, is checking that these numbers match up with the ones that we were given in our sequence, and it looks like they do. So that tells us that the closed formula for this sequence B sub n is this that we have right here, B sub n equals n times n plus 1 over 2, whole thing, plus 1. All right. So let's look at the second sequence now, the C. So notice in our sequence C sub n, sorry, the values or the index here actually starts with n greater than or equal to 0. So when we start plugging things into check, the first value that we're going to check is n equals 0, not n equals 1, like in our last example. Okay, but again, we want to look at these numbers and compare them to the known sequences that are above. So kind of looking at those, let's see. I would say they look a little bit similar to the powers of 2, but it looks like the numbers in our sequence Cn are all 1 less than the powers of 2, right? So 0 is 1 minus 1 gives us 0, 2 minus 1 gives us 1, 4 minus 1 gives us 3, etc. So hopefully you can kind of see that relation there. So what does that tell us? That tells us that our guess for C sub n would be the powers of 2 and then take away 1, right? So we want to subtract 1 this time. All right, well, what is the formula for the powers of 2? That's a sub n equals 2 to the n. All right, and again, we want to check to see if this actually makes sense with our sequence up here. So notice here that the index n bigger than or equal to 0, so the index is actually the same. Whoops, this formatted funny, but the index actually starts at 0 for both the powers of 2 and the sequence that we're given. All right, so again, just to check, we'll plug in n equals 0, which would give us, so again, plugging in 0 to this, 2 to the 0, which is 1 minus 1, which is 0, which is indeed the first number in our sequence. That's good. What happens if we plug in 1? 2 to the first is 2, minus 1 is 1. That's the second number in our sequence. That's good. If n is equal to 2, we have 2 squared minus 1, which is 3. That's the third number in our sequence. And I'll just go ahead and check one more while we're at it. So 8 minus 1 is 7, which is the next number in our sequence. And hopefully you can kind of mentally plug those in to check the next few. And that tells us that C sub n equals 2 to the n minus 1 is a closed formula